I'm going to talk about less painful serverless deployments. Yeah, as I said, I wanted to name this talk differently, but I think this is fair to state that there are still challenges because serverless itself is quite recent tech. It's only exists for 3 years, but the concept exists for way longer. A little bit about me. I'm Pavel Kruhlei. I'm originally from Belarus. I'm a quality engineer lead in Newton, responsible for everything related to quality. Before production, meaning test automation, and after production, meaning operations, monitoring, observability, alerting, all sorts of things. I was working in small and big companies. I have like 12 years of experience, and a big believer in DevTestSecWhateverOps means that you are owning what you do completely. You don't need to go to, I don't know, the server guy to deploy things. Outside of office, I jump out of planes and climb mountains. Maybe one day we'll combine these two, but not now. long future. A little bit about Newton. So we are a fintech. We are a digital lender. We help businesses from 1 to 10 people to get finance. We give them a loan. What really distinguishes us on the market of lending is that we do everything online, so all the signatures are online. You don't need to call us, you don't need to send paper to us, all done through ID and signing, all digital. We very fast compared to the traditional banking. In traditional bank, if your business is going to take you like 2 months to get a loan, and maybe last day you will know that, sorry, we cannot give it to you. In our case, we already in 15 minutes can tell you would you be able to get loan or not based on the algorithms that we run on the financial data you provide us. And in 2 days, money will be on your bank account. So this, for me, really fast compared to the traditional banking. We initiated 3 years ago. We're 100% subsidiary of ABN AMRO Bank, so we kind of start up from the big bank, which means that we have both pluses of agility of startup and security and expertise of ABN AMRO. So that's in a nutshell what Newton is. We have more than 1,800 customers in 2 years, and we plan to grow internationally and locally in Netherlands. Our core beliefs related to DevOps, I think it's important to state before I move deeper in the serverless. We truly believe that ownership and responsibility can achieve the best results. So we 100% trust our software engineers with their choices of any tech, but we also 100% ask from them for any decisions. We want to focus on what is most important for us, what help us, our business to grow, and we are software engineers. We like to write code, so we try to do as much as possible as a code. Testing, deployments, infrastructure, everything. So that's our 3 core beliefs. Now moving to the serverless. How many from you guys tried some serverless or know what it is? Okay, quite a lot. So we'll try to run through this stage. Of course, it's not a miracle. It's not serverless. There are some servers running your software somewhere, but you pay just fraction of the time for the time allocations that you use. And in a lot of minds, serverless and we are 100% Amazon. Means Amazon Lambdas, but it's not true. It's all managed services. So Lambdas not equal serverless. Well, Lambdas are actually part of the serverless paradigm. And a little bit of Amazon names and Amazon logos going to be here. So it's Lambda, it's S3, it's DynamoDB, it's all sorts of things. And growing and growing and growing. Lambdas itself from last year support way more languages, including COBOL. Yay, BAMS, right? I really wanted to see on the reInvent this year this. Wait, why not? Something wrong with my. Yes, Perl, but it's not yet there. Maybe guys from Booking will be happy about that. Anyway. Quick intro, what is Lambdas are. Lambda is a function of the service, right? So it's complete abstraction of infrastructure. You don't care about where it runs, how it runs. In a nutshell, if a stateless container firecracker. If you think about technology behind it, it's micro-virtualization technology based on, I think, KVM. But doesn't matter. Lambda is triggered by events, and events can be different format. So it's triggered by events, and then it's do some processing and returns you a response. So events can be synchronous, like API. Lambda subscribe to API, stays behind API. We call API gateway of Amazon. I know post/user order, then it's trigger Lambda function. It can be asynchronous based on events on simplification service, like something happens, do something. And then Lambda will be triggered as well. It can be poll based, so Lambda constantly can poll changes on DynamoDB or any kind of Kinesis event bus and execute a function. So this is three basic ways to trigger Lambdas. How we approach it in Newton, how we approach serverless in Newton. So we 100% on cloud, 100% on Amazon, and we 80% on Lambdas since almost beginning when we started, so since 2 years. Which means that our runtime contains most of Lambda functions and the serverless applications. If you think about the DevOps paradigms that I showed you in the beginning, that's how Lambda really fitted. So it's helped us to focus on the business value. It helped us to focus on what we want to achieve, build only business logic code, doesn't build codes that help us to run things, doesn't allow us, well, doesn't impede us in this way. Lambdas are extremely fast to deploy and release because they are small in itself. They are really helping our DevOps concept or DevTestSecWhateverOps concept, because Lambda itself or serverless function itself is very small, very contained. So it's easy for one person to fully own it and fully understand it. If you think about growing, something that you run on maybe Kubernetes cluster, or something that you run as monolith, it's maybe a little bit harder. But something related to microservices built on the serverless, it's definitely possible to understand by one service owner. Lambda's monitoring are simple. You just need to monitor the application telemetry, the business logic telemetry. You don't need to think about CPU workload, disk space limits and stuff like that, because it's all abstracted by you by the cloud provider, Amazon in our case. And we minimize risk by delegating a lot to cloud provider. Means we don't need to think about, okay, there is a new kernel update because of Intel again did something wrong with their CPUs. So please, Amazon, think about it. We don't need to think about it and wake up in the middle of the night because we need to patch things immediately. So that's how serverless concept really fit our DevOps approach. So when we start moving to the Lambdas, first we tried just play it, like deploy from local machine or even from the Amazon console. But then we start growing and growing and growing, and we have more than 40 services now, and it's not possible, of course, to deploy it from any environment or any computer or any local machine. So we thought about choices how we're gonna manage CI/CD with serverless. At the moment, there are 5 options available. When we started, it was only 3. Oh, yes, 3. I don't know. First option is the Amazon CloudFormation. So it's basic infrastructure as a code concept from Amazon. This 3 is basically provided you by Amazon, and these 2 are independent. So CloudFormation is declarative language, how you explain, how you express your infrastructure, how you express your roles. But what I really hate is just the JSON templates. And when you think about big, complicated service with a lot of infrastructure around, it's going to be like we had service of 2,000 lines of JSON code, and it's a pain in the ass to understand and manage it. So it's, no, just no. I don't want to look at that anymore. Last year, Amazon announced SAM, Serverless Application Model, which is abstraction on top of CloudFormation, which is YAML way better to read, but still. It supports everything that's supported by CloudFormation, so it's just a total abstraction on top of it. Have open specification, open source completely, and have nice CLI tooling that allow you to do a lot of things like offline testing. Because before, offline testing was a little bit complicated. When you think you need to simulate completely runtime of Amazon, that's not easy on most of the cases because Amazon never tells you what is their API. That you have to guess, you have to think about it. And with SAML, they allow you to do it. And latest addition is Amazon Cloud Development Kit, which is not only working with serverless, but working with all of the Amazon infrastructure, any kind of service. So it contains the concept of constructs, which you can build in TypeScript or Python or any kind of normal declarative language. So you can actually reuse a lot of your infrastructure in different services. You can build components out of it, and then you don't need to repeat again. So I kind of like the concept of Cloud Development Kit. If I would be starting now, I might look at that direction, because it's again 100% supported by Amazon. That's what provided by Amazon. And something that outside of Amazon stack, Terraform, it's a way of explaining infrastructure as code, but in their own DSL, their own specific language, declarative language. It's used direct. Oh, by the way, I didn't tell. So CloudFormation is hell slow, really slow, because it's creating the kind of a stack of your infrastructure, deploying all of the services, validating them is deployed correctly. Terraform uses direct API calls. It's like working with Amazon CLI or Amazon SDK. So it's way faster, but it's not really transactional. So if something goes wrong with your terraformation of your infrastructure, you need to sometimes go understand, read, and do something manually. With CloudFormation-based tooling, so CloudFormation itself, SAM or CDK, there is just a stack that you can delete. And last is serverless framework. Serverless.com is a framework that's created by a community, open source framework for deployment and working with function as a service concept. It's abstracted from the cloud provider, so it's cloud agnostic. You can work with Lambdas, you can work with cloud functions, Knatives, I think, as well. So if you think about, I need to run my application multi-cloud, you might go with this one. It's as well kind of specification of your infrastructure when you say, okay, this is my service, it contains components, and component is S3 bucket where you store the code or where you do something. This contains the API gateway. This is full information about your endpoint, and this is actually an executable Lambda that will be run as soon as there is a request going to this endpoint. So you describe it. Serverless creates CloudFormation stack for you, deploy it to Amazon, validates that it's deployed, and you don't need to think about complicated YAML or JSON files of CloudFormation itself, and it's open source. And now they also release, it's in beta still, called Serverless Components. It's a very simple concept with Amazon Cloud Development Kit, so something that you can write even easier, you can build. So here, pretty much like all of the things, like API endpoints, S3 buckets, can be grouped in one component. It's just like, I want to deploy my website. The website should contain where you host the website, how you host it, APIs, and everything. And the component itself as well is TypeScript, pretty much code that you can reuse and you can build on top of it. So if you choose now what kind of deployment options or what kind of framework you would like to use for serverless, I would say go with serverless and components, or go with Amazon Cloud Development Kit. When we looked on the comparison, different frameworks, there are a lot of comparison on internet, but this was the most important for us: usability and developer experience and the stability of the framework. So I think serverless wins on Terraform and CDK a lot. It's really clean, and really complete, and really easy to start building stuff on the first day. So yeah, our choice is serverless. This is what we do. This is how we manage our serverless microservices. But there are problems. Problems is persistence of infrastructure. We want to have everything as a code. We want to have everything in the repository of microservice. But if you think about microservice needs to use databases, and when you create everything with CloudFormation, if something goes wrong, if you need to delete a CloudFormation template or CloudFormation stack, all of the resources created by the CloudFormation will be gone, just like thrown away, and new resources will be created after you rerun it. Might be not the best thing to do with databases in production. Like if you have your user data, you don't want to just wipe it up because you forgot some fields. So persistence of infrastructure is a trick one. Then we have a lot of services. We have 42 services, a magic number, really proud of it. And of course we have 42 ways of deploying it, because every service, every pipeline belongs to someone, and it's easy to desynchronize how you do things, And then when you have to change something, it's a pain, and yeah, standardization is the fun with this, right? If you want to say, we want to deploy everything with secured and protected APIs, with the web application firewall in front of it, and we want to deploy everything with protected and encrypted databases, protected and encrypted S3 buckets, you have to multiply these changes in 42 pipelines. Once I did it, and never again. And we still run 20% stuff on the containers, so not microservices. Not serverless. Means that we have to have two standards of everything, every deploy. So when we thought about how we're gonna move forward 1 year ago, we were like, let's just merge two tools together and see how we can work and with the benefit of both of two. So yeah, we came with a toolbox. Toolbox is our tooling that it's a command line utility that bridge both Terraform and the serverless frameworks together. So you create persistent resources by Terraform, so databases, S3 buckets, and everything. And with serverless, you manage everything else, and everything is contained in one repository. All of your Terraform templates, all of your Terraform code, and all of the serverless code is one repo. It's a Go-written tool based on the Cobra CLI tool. And it's also packaged as a Docker instance, so anyone don't need to think about, okay, now I need to install Go runtime in my laptop to be able to use it. Or I need to provision Go runtime for our CI/CD pipelines. So it's quite easy for developers to start using the toolbox. It can deploy anything. It can deploy serverless, can deploy the microservices, can deploy pretty much all of infrastructure. It's enforced standardization, because if you say Terraform deploy, this is a command that we use to deploy, it will ensure that everything is encrypted, it will ensure that everything is secure, it will ensure as well that you do have a monitoring for your microservices. This goes to our monitoring solutions. Datadog in our case checks that for your service there are dashboards and there are alerts, and it's going to check that there is services set up in our alerting tool in the PagerDuty. So it's make sure that you deploy completely observable, completely secure service from day one, and it will even help you to set it up if you forgot about it. But it will show you, okay, you forgot about PagerDuty config. Do you want to create it for me? You say, yeah, I want to create PagerDuty. What's your service name? How are you going to be triggered? How are you going to be notified? And as well, it helps engineers to get latest changes really fast. Because it's a Docker image, so if you use latest version of Docker image, you will get everything. You will get new checks for secure pipelines. You will get auto completion or auto generation of the observability tooling, you get pretty much the full set. So that's our way how we manage serverless deployments. We use Terraform, we use serverless.com framework, we merge it together in the toolbox, using the toolbox CLI. This is our continuous delivery pipeline. A lot of small little things, but first we use the normal master and the feature branch strategy, right? So if you develop something in feature branch, you can deploy it to our dev and test environment from any feature branch. It will run all of the chaos and unit tests first. It will run all of the kind of system integration and consumer-driven contract test after. It will publish your API client if tests are passing, so you publish your API documentation to other services. When you are done with the feature branch, you move to the master, and on master you can deploy it to acceptance, and you can do more validation, more extensive testing. And from master, from any commit, still it's a manual step, you can create a release. Create a release will automatically create a branch. It's also done by the toolbox. Publish everything, your changes to the release branch, and deploy to production. So our continuous integration is continuous. Our continuous deployment is a little bit like, okay, press button. Yeah. So, and the goal for this quarter is make it complete. So you don't need to have this create release. You can always deploy from master. That's it. Yes. Any questions, guys? Because I think I was talking too much and too fast. Yeah, sure.
You just said that you wanted to do the continuous delivery part this year. What kind of steps do you want to take to accomplish that?
Way more extensive testing, because now we do have it, but I want more. I want more coverage on API, and I want more contract testing, and that's only things that blocking us. So basically, we achieve continuous deployment when we're confident enough. When we're confident, when you have all sorts of tooling and tests to say yes, yes, good, go. And as well when you have good rollback strategies. Because not every time you can roll back, especially if you do database changes. So when we will fix this, it will be done.
I like what you're talking about doing everything as code. I'm curious if there's anything you haven't been able to do as code yet, or what was the hardest part?
Good question. We do all the testing as code, so unit, contract, integration, end-to-end. We do infrastructure as a code. We don't do everything in observability as a code. For example,
okay.
I wanted developer to type, okay, I release the service price, and I want to monitor everything related to price, service invocations, time to leave, or time to request, time to round trip of request, errors, this kind of things, just in a YAML format, or we call it new time manifest, we're working on it. And then it will auto-generate all of the monitors and all of the alerts. So that's still something you have to go and manually configure in the monitoring tool. That's next step for us. We do validation if this is present, but we don't yet generate it.
Sure.
Yeah.
Good, thank you.
I probably missed this part.
Yeah.
So how do you manage secrets?
Secrets?
Yeah.
So there is a service called Parameter Store, Amazon Parameter Store, managed service. Every service, when it needs to access something else, goes there, check. Give me secret by this key.
Is that like a vault?
Huh?
Is that like a vault?
Yeah, very similar to the Terraform vault. Yeah. But not something that you manage. It's a managed service by the Amazon.
So it is like a just-in-time, it will go ahead and create it.
Yeah, round trip is around 25 milliseconds for request. So it's a little bit of overhead, but we don't do high frequency trading here. We do business to business loan applications, So 30 milliseconds delay on the request is okay.
You said you have 20% in Docker
Containers, yeah,
containers,
Docker.
and why didn't it fit into serverless?
Not everything is making sense to put in serverless yet. So the serverless, really good concept until you hit the limit of Lambda startup time. Because every time Lambda starts, it's basically micro container booting up somewhere. So when you there are concept of cold start and warm start. Cold start means that it's completely not existing before, it's just booting up. And warm start is when this microcontainer already running and it's just second invocation. So warm start is about, I don't know, also 20 milliseconds. Cold start can be up to 3 seconds. So if you do something that require user interaction, or if you do something on the front end, you don't want to have the 3 seconds of delay. There are workarounds about that, but really something that have high load, high frequency, it's maybe not the best for now. So we still use the containers for that. Yeah.
So if your deployments fail, do you have any rollback, automatic rollback?
The stack will be deleted. All of the infrastructure and all of the service that's supposed to be there will be gone. So if deployment is failed, it's automatic rollback. If deployment is succeeded, but the application is broken, we detect it by testing or we detect it by customer calling us, there is no automated rollback. We have to roll back manually. Or we have to roll forward, like fix it and roll forward. Most of the time we roll forward.
There is no plan to?
Yeah. This year, Q1, Q2. Someone else? Time to give a stage for next speaker? Please. Thanks, guys.